Last October, I was thinking about the titles that I'll propose for my thesis. I continued reading one research after another, but nothing seems to work. I stopped and reflected. I want my thesis journey to be worth the time and effort, not just to be a time consumed to have a master's degree. So in this presentation, I'll talk about my motivation and my study entitled Development of the Spaceport Layout Design for the Philippine Space Agency in Balabac, Palawan. In Celera's article written last year about the Asian space race, it seems that the Philippines is lagging behind its neighbors such as Malaysia, which created its own space agency in 2002, and Indonesia, which has been operating its satellites since 1976. Finally, in the advent of the Philippine Space Agency through the release of Republic Act 11363, also known as the Philippine Space Act, the Philippines officiated its aim to keep up with the other space programs worldwide for a combined effort to further humanity's space development and operation. That information was taken from Paroch's 2019 article about President Duterte signing the law which creates the Philippine Space Agency. Well, honestly, I thought this would be easy. Unfortunately, upon searching for acceptable standards and recommended practices for spaceport design, I've learned that the space agencies worldwide have their ways of designing their spaceports. Yes, there were no SARPs. With this, I challenged myself not to gain attention, but for the love of the country. The purpose of this study is to develop a spaceport layout design for the Philippine Space Agency, with Balabac, Palawan as the location for the launch facility. Since there were no SARPs, I ended up gathering information about spaceport design from almost any source possible. Because of this, in the first part of the study, I chose to test my preferred location based on the Center for Strategic and International Studies considerations in terms of geographical and political variables. The second part involved the case analysis of 8 existing spaceports such as Guyana, Naro, and Tanegashima Space Centers, New Zealand's Rocket Lab, Baikonur and Plesetsk Cosmodromes, Pacific Spaceport Complex, and the famous Cape Canaveral Spaceport. Simultaneously, in the second stage of this study, I was also conducting key informant interviews and the exchange of emails with the participants of the study. Using the method of triangulation, I processed the data, derived from the first 2 stages of the study, to come up with the design criteria which guided me to create my spaceport layout design, in which I used a software called SketchUp Pro for my digitized model. Now, let's look at the content of the study. With my first statement of the problem, what makes Balabac, Palawan a suitable location? Findings say that Balabac is indeed a good location for the spaceport, except that the accessibility will be a challenge since it lies at the southwest bottom of the Philippines, which means transportation of raw materials or payload will be challenging. Moreover, the location is the best, unless it becomes a UNESCO site, with which my study will then just become an essential reference for spaceport design, which will be located somewhere else in the country. On recommendations, since this is a complex study, researches like this would benefit if someone could make a comparative study about suitable locations within the Philippines for a spaceport. That would really help in terms of time, most notably for time-bound researches like this one. For the second and third SOPs, such as queries on the design perspectives and design standards, findings can be summarized through this table. Conclusions, on the other hand, state that comparison of active spaceports through case analysis is achievable despite the limitations in available references. I overcame this limitation by using Google Earth to see actual images of the spaceports as well as to have reliable measurements regarding dimensioning and spacing. Furthermore, I recommend that we follow design perspectives used by designers on studies like this, as well as published standards in textbooks and technical papers. For the last SOP, regarding the spaceport design general considerations exclusive to the Philippine setting, findings led the study to adopt into the design criteria 3 considerations. These are the airport facility to aid the accessibility problem as stated in the findings of the first SOP. The Makabayan perspective, which promotes the usage of colors blue, red, white, and yellow on the structural facilities. And green architecture, which will promote good environmental relationship between the spaceport and the flora and fauna of Balabac. With this, we can conclude that the triangulation method avoids bias when it comes to which response or data should be adapted. The study recommends, on the other hand, that the use of simulation software can make a design's reliability better, learning from the inability of this study to use such due to its time frame. Moreover, the needs of the society in the location chosen for the spaceport design must be studied as well. Let's take a look at the spaceport design. Welcome to Balabac Spaceport. This is the layout plan on which the facilities are distributed on the landmass of Melville, Balabac, Palawan. Following the design criteria as presented earlier, the launch pad was designed to face southeast. This is the airport and it has a runway length of 3,219 meters. With its control tower and the terminal buildings, it is expected to solve the problems with accessibility for a better spaceport operation. This is the Operations Control Center. As the facility with most sophistication in its design, it is characterized by its embellishment, which is the monkey-eating eagle, dubbed as the Philippine national bird. Moreover, it houses the launch control area and a reception area and other compartments needed for the spaceport operations. With multiple compartments containing facilities such as the airlock bay and some offices, this is the payload processing facility. It is equipped with a gantry within its 10,403 square meter facility located 1.5 kilometers away from the launch pad. The chosen fire protection for the spaceport includes a fire department within the vicinity. As can be seen in here, just 500 meters away from the launch pad, roadways are strategized in a manner that the spaceport firefighters will have a good access to the launch pad in case of fire. The tallest structure in the spaceport vicinity is the assembly building. It can house 2 rockets at once with its 2 bays allotted for assembly of the payload and the launch system. Although a blockhouse may be considered optional, the researcher included such a facility in the design. Hence, as per the requirements, the blockhouse bore the flag colors and was semi-underground as can be seen in here. These are the propellant storage, where the containers are housed within hangars to ensure protection from the sun's heat. The distance of both facilities is 150 meters from the launch pad. Following Tanegashima Spaceport Center's launchpad shape, the launch area shown in here is equipped with flame deflectors similar to NASA's Cape Canaveral Spaceport, where the launch base is elevated and compartments beneath it where exhaust gases escape is visible. Furthermore, four lightning towers surrounding the launch pad are 75 meters high. The roadways in here depicts simplicity, while the visible adaptation of Tanegashima Spaceport's divided roadways can be observed. These are the references used in the study. Thank you for your time, and may God bless all of us and our country.